Hello everyone, welcome on our YouTube channel Physics Made Easy Kota. In this video, we are going to learn about the chapter Atoms and Nuclei. Rutherford failed to explain the stability and the spectrum of an atom, but Bohr explained these very well. So now we are going to learn about the postulates of Bohr's atom model. Made the various assumptions like the number 1, Rutherford's model of atom is acceptable to the extent that an atom has a small positively charged core which is called as nucleus, where whole mass and positive charge of atom are supposed to be concentrated. Also, an electron can revolve only in those energy levels in which angular momentum is integral multiple of h divided by 2 pi. Here h is the Planck constant. This is also known as the Bohr quantization condition for angular momentum. Third postulate is that an electron revolves around the nucleus with a definite fixed energy in a circular path of fixed radius, and these are known as the stationary state without gaining or losing energy. An electron emits energy in the form of photons or radiations when it jumps from the higher energy level to lower energy level. So here two energy levels are shown. Whenever an electron comes from the higher energy state to lower energy state, there is also emission of energy in the form of photons. Hydrogen atom consists of nucleus having charge plus C and electron that is revolving around it having the charge of the same magnitude but of the opposite nature. The electron is assumed to be revolve around the nucleus in the circular orbit of the radius small r as shown in the figure. Now we have to calculate the speed of the electron in terms of the radius of an orbit. The Coulomb force of attraction between the nucleus and the electron revolving in the orbit can be found by using the formula F is equal to K Q1 Q2 divided by R square. Here we can replace the Q1 Q2 with the magnitude of the charge on the electron as well as on the nucleus, that is small e, and this provide necessary centripetal force for an electron to move in the circular orbit of the radius r, and that centripetal force is responsible for its motion. So Coulomb force of attraction is balanced with the centripetal force. So we get the equation centripetal force is equal to electrostatic force that is given by the Coulomb's law. So mv square divided by r is equal to k into e square divided by r square. So these forces are balanced and these forces act on the electron. Then further cross multiply the equation and we get the answer for the speed. So now the next topic, energy levels of hydrogen atom. The energy of hydrogen atom in the nth orbit or the nth energy state is given by this relation En is equal to minus 13.6 divided by n square in electron volt. Now we are going to calculate the energy for the each of the orbit. For that, first of all we consider when n is equal to 1. In this case we say that the electron is revolving in the innermost orbit, which is also known as the orbit closest to the nucleus. This is the lowest energy of hydrogen atom and we can calculate the energy by using the relation of the En, and the answer for this is equal to minus 13.6 electron volt. So here this energy level is the ground state of hydrogen atom. When hydrogen atom has the lowest energy, the atom is said to be in the ground state. So now when we can replace n is equal to 2, in this case the electron is revolving in the second orbit. So the energy of the hydrogen atom is En, here n is equal to 2, is equal to minus 13.6 divided by 2 square, and we get the final answer minus 3.4 electron volt. This is the energy of the first excited energy state of the hydrogen atom. Now when n is equal to 3, this is known as the energy of the second excited state of hydrogen atom, and for this energy is equal to minus 1.51 electron volt. Similarly, we can also calculate the energy of hydrogen atom for the orbit is equal to infinity. Here energy is equal to infinity. This is the energy of highest energy state of hydrogen atom. It means that when n is equal to infinity, the electron is completely free from the attractive forces of the nucleus of the atom, which means that the electron is no longer bounded to the nucleus. So here energy of hydrogen atom in different states or level is represented by horizontal lines. The energy level in an atom are discrete, they are not in the continuous form, and a diagram that representing the energy of different state of hydrogen atom is known as the energy level diagram. So this figure representing the energy level diagrams. Solid, liquids and gases, they emit the electromagnetic radiation at all temperature due to the oscillation and interaction of their atoms and molecules. These radiations have continuous band of many wavelengths of different intensity, but less dense gases on excitation emit some clearly separate or specific wavelengths which appear to be the series of bright lines. These radiations are due to the atoms themselves and not because of the interaction between atoms and molecules. So from this we come to know about the line emission spectrum and the line absorption spectrum from these radiations. For line emission spectrum, it is a series of lines of various wavelengths emitted by an atomic gas or vapor, usually excited by electric current passes through them, and the spectrum produced by radiations emitted by excited element is known as the characteristic spectrum of the element. So when electric current passes through a discharge tube containing small amount of gas or vapor of certain elements, like we can say mercury, sodium, and they are present at the low pressure, then light is emitted. So when this light is allowed to pass through a prism, a spectrum consisting of spectral lines of some definite wavelength is obtained on a photographic plate on a screen, and this spectrum emitted by atomic hydrogen, and they are such that their background is black, and these are the bright lines are known as the light emission spectrum. So here is the hydrogen emission spectrum, and this spectrum consists of the bright lights and their background is dark. This diagram clearly explains the theory that when a gases is allowed to pass through the prism, then the lines of the different wavelength is formed on the photographic plate or a screen. Now next is a line absorption spectrum. When white light passes through a gas or a vapor, then the spectrum of transmitted light observed with a spectrometer, which shows some dark lines which replace some bright lines seen in the emission spectrum of the gas. So such a spectrum is known as the line absorption spectrum. So now various spectral lines of hydrogen atom spectrum is obtained. The question arises, what is the spectral lines or what is the spectral series? Spectrum of element have wavelength that show definite regularities which can be classified into certain groups are known as the spectral lines. That the lines which create the certain group separate from each other are known as the spectral series. When electron jumps from higher energy state to the lower energy state, or we can say the lower energy orbit in the hydrogen atom, then the radiations of particular wavelength or frequency, which is known as the spectral lines, are emitted, and the wavelength of the spectral lines depend upon the energy between the two energy states. in which transition of electron take place, and the spectral lines emitted as a result of the transition of electron from higher energy state to a particular lower energy state form a spectral series. There are the large number of the spectral series which can take place for the hydrogen atom spectrum that we are going to learn one by one. The first one, that is known as the Lyman series. So you can see in the figure, Lyman series is representing the spectral lines emitted due to the transition of electron from any higher orbit. That is, we can take the higher orbit when n is equal to 2, 3, 4, so on up to infinity, and their transition taken to the first orbit n is equal to 1. Then these series are known as the Lyman series. So when the transition of electron from the higher orbit when n is equal to 3, 4, 5, 6 so on up to infinity to the second orbit, or which is also known as the first excited energy state, then they form the spectral series which is known as the Balmer series. Similarly, for the Paschen series, when the transition of electron from any higher orbit, that is for n is equal to 4, 5, 6 so on up to infinity to the third orbit or second excited energy state, that is n is equal to 3, they form the spectral series which is known as the Paschen series. And for the bracket series, the spectral lines emitted due to the transition of electron from any higher orbit, that is n is equal to 5, 6, 7, 8 so on up to infinity to the fourth orbit, that form the spectral series which is known as a bracket series. In this way we get the next one, that is also known as a photon series. So these are the spectral lines of the hydrogen atom. All these series have their particular wavelength. Thank you for watching. Take care. Have a nice day.